Hi, we are continuing with our neetcode in 60 days. Explain the logic. So the logic is pretty simple, I think. So we are making a prefix sum with logic with adding each values here, and on this one we add here, add left, add top, add current value, and we remove from diagonal. And we are creating such such prefix. And here we actually do this in these two loops and save it in A. And then we have sum region. So how it works? So sum region, we have 2 points, for example, here and here. And if we will take a look, it's actually looks like rectangle, right? So to get this one, we need to take one row up and the same column. So we remove this part, and also we remove this part. But as we remove this part too, we actually need to add the diagonal here. So this one. And also we add some from here. So the logic is pretty simple. So we take this value and we try to remove this one, and add what is left, because it was removed 2 times. And that's it. So task is pretty simple one, so we just make it completed, and we are going to the next task. Okay. So let's start. So first definition, and let's read. So we are given an integer array nums, return an array answer such that answer I is equal to the product of all elements of nums except this value. Okay, so the product of any prefix or suffix of nums is guaranteed to fit its 32 bits integer. Okay, so you must write an algorithm that runs in linear time and without using the division operation. Can you solve this problem in without extra space complexity? The output array doesn't count as extra space for space complexity analysis. All right. So we have an array, right? And we should return another array, correct? So for example, we have array 1, 3, 4, 2, and we should return, so for example, on this one, we should return product of all other elements. So for example, 3 multiplied by 2, 6, 6 multiplied by 4, 24, right? So we put it here, 24. So without 3, we have 8. Then without 4, we have 6. And here without 2, we have 12. So this would be our result array. Let's think about constraints. So first of all, it's our array length. So there's definitely we should implement in ON time. So if it's ON time, so I believe it's something like 10 in 7 power. Also, when we have some values, yeah, so it's mentioned that it's like not big values, so it's like 30. And also we have a definition that we don't have overflows. So we don't have overflows here. Third one, test cases. So let's go with test cases. So with test cases, we can have the following. So like this one test case. Also, yeah, so we have at least 2 elements. So this one test case, so this one would be 1 and 2. Yeah. What is interesting, like for example, if we have such test case, then we have all zeros here, except this 0, because here we have like multiplication of everything, so it will be 24. So can we actually optimize this somehow? So for example, if we have two zeros in our array, then we always have 0. If we have only 1 0, then it means that we should multiply all our values and just return all 0 with these values. But if we don't have zeros, so I believe we can we can do this prefix sum. And how to do this? So let's think if we don't have zeros. So how we can do this? So let's think about prefix sum. So 1 multiplied by 3 is 3. 3 multiplied by 4 is 12. 12 multiplied, it would be 24. And if we take out, for example, 3 from here, I need to have 12, right? And how can I get 12? I can go from here. So what I can do, another way, I can just multiply from back, so it go to 8, then 24 to 8, and then 8 multiplied by 3, 24, and 24. So we have prefix and suffix. And now I need to get out of this one. It's not 12. Okay, so I think it would not work. So what if I have prefix sum, right? So something like this. Then I have suffix, so it would be 2. Then it would be 6. Then it would be 9 and 10. Yeah, so it doesn't give me something. It doesn't give me some thoughts, so I cannot use a division operation here. Cannot use division operation. Okay, so for 1, 3. Okay, let's do once again this 1, 3, 12, 24. Then I have 24, 24. And then I have 8 and 2. Okay, so if I want to take for 1, I take this one. Oh no, I take this one, right? Then I take 8. 3 multiplied by 8, or so I start with this one, then I have 8, then I have 3 multiplied by 2, and I have all these values. Yeah, because if I didn't take this one, it's actually sum of all these things. But if I go to this 3, right? If I go to this 3, I need to remove 1 and then 8. So I need to multiply 8 by 1. Then when I go to 12, I need to multiply 3 by 2. Yeah. Okay. So I have, yeah, I think this prefix and suffix should work. And the logic should be the following. So I first collect all these things, and then I start yeah. So I start where should I start? Yeah, I start probably from 1. And I have 24. Yeah. So I have my int like results array, and what I can do, I can iterate through result length I++, and then I can put into I so it would be prefix and its suffix. Okay. Yeah, so let's continue. So when I have 0, it means I should take from suffix the next one and from prefix the next one, and I should multiply them. So in this case, yeah, so in this case, I should check. So if I is equal to 0, right? And so I take 1. Otherwise, I take from prefix I minus 1. And then I multiply this value by another value. So here I take suffix, and if I is equal to result length minus 1, right? So I start with 0, Then I have 3, 8, 2, 6, yes, and here. So yes, so when I'm on the last element, it means that I take 1. Otherwise, I take suffix I plus 1. And yeah, and I return the result. So I think it should work something like this, and then we have one loop. We have prefix and suffix. So I believe that with result, yeah, we can somehow optimize this one to use only a constant time. But yeah, so let's try to implement this. So I have my result array that have the same length as this one, right? I can also optimize this algorithm by counting zeros, but let's do just the general case. Also, I have another array, it's prefix, so the same length, and also suffix. Yep. So I have these 3 arrays. Then what I do, I iterate first from the beginning till the length I++, and I increase my prefix I is equal to I think I can start with 1, and it will be like multiply by pref I minus 1. So it's first one, and another one we start from nums length minus 1 and I minus minus, and then we put on prefix I multiply by prefix I plus 1, and then we can start with minus 2. So we have here its suffix. So we have prefix and suffix, and now we just can take this array, and yeah, and we just update this array with prefix and this one with suffix. We can return result. So let's run it. Yeah, so here minus minus. Okay. I is greater or equals 0. So let's check why it doesn't work. So all zeros. Yeah, so before we start, we actually should put onto the 0 like nums 0, and here we should put into the end, we should put minus 1, we should put nums. Yeah, the same value. And I think it should work. Okay, it doesn't work. What can be the problem here? Yeah. So the problem here is the following. So we should put here nums and here nums. Okay, so it still doesn't work. Still doesn't work. Let's print what we have in suffix and prefix. System out println arrays to string, and we have prefix, and let's also print suffix, and let's see what we have. Do we have correct values? Yeah, and we see that we don't have correct values. So yeah, so I believe here is a problem, because we should do the following. We should yeah, we put this first element here, and then we want to do the following. We should take pref -1 and multiply. Yeah, and we want to multiply this by current num, right? Something like this. Yeah. And the same we want to do with suffix. So suffix will be I plus 1. And we multiply by nums I. Let's run. Okay, now it works. So let's submit. Yeah, and we see that it works. So let's check our submission. We see that here we have, yeah, the same logic. We submitted it like, let's check here. Yeah, so pretty the same logic. Pretty the same. What about editorials? We don't have. What about solutions? Okay, answer. Let's divide the product array with numbers. Yeah, prefix suffix is this one. Find the prefix and suffix product. Yeah. So it sets our solution and directly stores the product for in the final answer. Okay. So yeah, so we solved today's question, and let's mark it down. And that's it for today. Thank you, and see you next time.